Hi, everybody. My name is Pauline, and today I want to talk to you for a few moments about my project where I was curious of whether or not geography had an effect on the abundance of extrafloral nectaries and ants who were attracted to those extrafloral nectaries. What I found in my project that though geography is a large factor in the abundance of these extrafloral nectaries and the ants, it is not the only factor. And I came to this conclusion because when I compared all the sites, I found two sites, Marangaba, Brazil, and Africa, to be statistically the same despite being on two different continents. So first I made this bar graph here, and when you look at this bar graph, you can see that the extrafloral nectaries throughout most of Brazil are very high in abundance, while the number of ants, the average number of ants, is quite low by comparison. Yet when you look at Marangaba here in Brazil and Africa over here, you will notice that they're very similar to each other, which is very different from the rest of the sites. Over here is a table that actually breaks down these numbers and shows you the actual values. So either way, you will see that the number of ants in Brazil and in Marangaba and Africa are much more similar to each other than the others. So, but graphs can be deceiving, right? So I wanted to run another analysis to make sure that these really were similar or different. So I decided to run a couple of ANOVAs. And over here, I ran two ANOVAs between all the sites as a whole, one of the extrafloral nectaries and one of the ants. And what you can see is the p-values are very small in this one, indicating that they are all very statistically different from each other. However, when I took Marangaba and Africa out of the equation and just compared them to each other, you'll notice that the p-value becomes much larger. So much larger, in fact, that these are essentially no different. This p-value greater than 0.05 here. This one here is 0.15, and this one over here is 0.66. They indicate that these numbers are not really different, that they are, these sites, the variance is not, they're the same, which is quite fascinating when you consider that not only are we on two different continents, but we're also looking at two different plant species here. This is the plant species in Brazil, and this is the plant species in Africa. So why does it matter though? One of the big things we can do if we understand how these extrafloral nectaries work is we can develop ways to come up with more environmentally responsible methods for pest control. And it'll also give us an idea of how these relationships may change according to climate change. Like what's driving these relationships? How is climate affecting those? How may it affect it in the future? The way I did it, I took the data from one paper, this paper over here, Geographic Mosaic of Plant Evolution, and I added up all the different EFNs. The scientists in this paper here, they localized the EFNs on it, whether the basal abaxial side, the abaxial higher up, or the adaxial. So I totaled all those up, added them, and then I matched that up with the number of ants on each tree. And then in the second paper, I needed to look at the data prior to their treatment, but they still had the number of ants on 3 different branches and the number of EFNs at 8 different nodes, which in the previous paper, they were only looking at one particular node and one particular plant. So what I did for this paper was I added up the numbers, I totaled them, and then I averaged them, and I used the average numbers for my comparisons to the prior paper. And that is my project. So thank you all for listening. I hope you all stay well and take care of yourselves out there.